Thanks for the introduction. Hello everyone, my name is Yunfeng Zhao. I am a PhD student at Queen's University, Belfast, and also working in the European Union Marie Curie Training Network's Food Smartphone project. It is my pleasure to be here today in Montreal and IEEE Census 2019 conference to represent our co-authors to present our latest work entitled Smartphone Modulated Colorimetric Reader with Color Subtraction. So can we test our food using our smartphones? The main objective of our food smartphone project is to paradigm shift the traditional personnel and resource-demanded lab-based food analysis approach to a new smartphone-based, consumer-friendly food analysis approach. Such a smartphone-based food analysis will enable early screening of food samples by normal consumers and will tremendously save the resource required by the suspicious food analysis in the lab. One way to achieve such smartphone-based food analysis is coupling smartphone with biosensors for food analysis. And interpreting color change of optical biosensor using smartphone camera is one of the major approaches for such smartphone-based biosensing. Currently, color intensity, colorimetry, fluorescence, and spectroscopy are the major optical mechanisms used for such smartphone-based to implement such smartphone-based optical biosensing. Even though the devices reported in the literature have achieved remarkable sensitivity and accuracy using the sophisticated optical mechanisms, most of them can only fit to one specific smartphone model and a certain analysis. This will inevitably limit the applicability to be used by normal consumers in everyday scenario. In this work, we present the smartphone modulated colorimetric reader that consists of a smartphone case module to support most smartphone models on the market, a light box and external light source module to enable multiple normalized dining conditions, and an IC platform module to support multiple IC platforms such as test strip, laser flow devices, and microfluidics. The image on the left shows the 3D rendering of the developed 3D reader model, and the two images on the right shows the 3D printed prototype attached to an Android smartphone and an iPhone. And talking about 3D printing, a prototype of the developer reader can be 3D printed by using a very basic 3D printer that costs less than 200 pounds on Amazon. And the spool of material can print approximately 6 of those prototypes, making each one less than 3 pounds. And the smartphone case, commercial smartphone case, costs less than 3 pounds nowadays, making the total cost to produce such a smartphone reader prototype less than 6 pounds. This is a price that is affordable by people living in resource-limited regions. Controlling pH is essential for winemaking. Currently there are two ways to measure pH of wine samples by normal consumers, either using pH test strips or using a handheld electrochemical pH meter. However, when people buy pH test strips online that are claimed to be designed for wine pH testing, they found that they are unable to test pH of red wine due to the red color interference. And lots of negative review readings were given because of that. Even worse, if the red wine sample volume is too limited to cover the electrochemical pH meter sensing probe, then there will be no solution available to test pH of such wine sample. In this work, we have proposed a novel color subtraction algorithm to subtract the color interference due to the color solution in the software pipeline. And the overall workflow of the software pipeline is shown in this diagram. Firstly, the color intensity nonlinearity profile is calibrated using one image taken by the smartphone camera. Then, the test images taken by the same smartphone camera will be illumination corrected using the nonlinearity profile calibrated. As you can see in the second image, a solution color catcher is added on every conventional pH test strip to collect the color of the solution. And the color of the solution will be subtracted from the color patch of pH test strip by applying the novel color subtraction algorithm we have proposed. Eventually, color value of colored solution can be predicted by applying color regression on the subtracted color. pH test strips are also commonly used to validate portable colorimetric devices in the literature. In total, 5 different experiments were conducted to validate the developed colorimetric reader in this work using pH test strips. A lab-based pH meter was used to produce the true pH values. And the first 2 experiments were conducted using transparent pH buffer solutions. The result of the first experiment has indicated that the developed reader has achieved approximately 4 times better accuracy than human visual interpretation and a state-of-the-art device reported in the literature on measuring pH test strip in terms of average error in pH value. And the second experiment evaluates the overall reproducibility of the developed reader. And the result has shown that our reader has achieved a high reproducibility across the tested smartphone models. And interestingly enough, we have observed that the lower-end smartphone models, on the contrary, produce a higher accuracy. We think the explanation is the more sophisticated image post-processing procedures embedded in higher-end smartphone models. The third experiment shows the proposed color subtraction algorithm 2 outperform the existing color subtraction algorithm 1, which suffers from severe performance imbalance on different colors. And the last 2 experiments validate the applicability of the developed reader. pH change of milk samples exposed in room temperature in 6 different days can be roughly monitored using the developed reader. And the pH of 3 different real red wine samples can be more accurately measured using the proposed color subtraction algorithm than without using. To conclude, the smartphone modulated colorimetric reader developed is the first smartphone colorimetric reader with the modulation concept built in to support most smartphone models on the market, multiple external light sources, and assay platforms. It is also the first colorimetric reader that is capable of measuring pH value from colored solution, for example, red wine. In total, 5 different experiments were conducted to validate the developed reader, and the results have shown a high applicability of the developed reader to be used by novel consumers for real food analysis applications. In the end, I would like to thank all the people and organizations, including but not limited to those listed in this page, for their support on this work. And thank you very much for your attention. I'm open to questions.
So, thank you very much for this nice talk.